Hello students, Eric Magidson here. This is part 1 of chapter 1, introducing today's technologies lecture. So this is how you'll get your lecture for this class for the parts that we use PowerPoint. Now, in other portions of the class, we're not going to talk about and use PowerPoint when we're talking about Microsoft Word and Excel and PowerPoint itself. Those are going to be demonstration videos on how to use the features and functionalities of those software. But before we talk about the software, we need to understand the computer itself. So this would be like, just knowing how to put gas in a car without understanding what's underneath the hood. So let's take a look here real quick. We've got some outcomes that you can go ahead and pause this video if you'd like and read through. But I'm going to discuss this content as we go through the multi-part series videos covering chapter 1. Now, if you'll notice down here, these pages here coincide with your digital book or your physical book. So if there's something that you want more information on, you can read about it in detail on your book, and you can also complete the SAM Cengage activities associated with this as well. Remember that although I don't assign each and every SAM Cengage activity, there's marvelous trainings with additional videos. So if there's something that I've said that you don't quite understand, feel free to go over to SAM, watch their videos, read their content, and you're bound to get this. So today's technology, what is an impact? Everything. With the advent of the internet, we've essentially come full circle as it pertains to computing, and technology is everywhere. You've got examples here, smartphones, laptops, tablets, music players that aren't smartphones. Do those even exist these days? Digital cameras are computing devices. Buy a new car, you've got Bluetooth technology integrated in it, you've got GPS integrated in it, your phone, such as Android Auto, is probably integrated into the automobile as well. So you've got a ton of computing devices in and around your daily life, including that smart TV that you bought that you no longer need to have a cable box because it's got a computer in the back. It'll connect to YouTube. It'll connect to the internet wirelessly without a computer connected to the television. So let's go through a few things. Digital literacy involves having a current knowledge and understanding of computers and mobile devices and the internet or the web. We're going to talk about the difference between the World Wide Web and the internet. So in this case, the web is what most of you all are familiar with, but we'll talk about that in another chapter. And of course, related technologies. So technology is just growing leaps and bounds. Amazing the things that we're doing with technology and with computers today. So what is a basic computer? It's an electronic device. We know that it's digital. Why is it digital? Because it understands only two things, ones and zeros. Now, before digital, we had analog, and what we would do is take an analog signal that was sent over a phone line, and it would be converted via a modem, a modulator, to a digital signal, a series of ones and zeros that the computer could understand. So when we talk about all the amazing things that we're doing on computers and smartphones and computer integrated soundboards like the one I have sitting in front of me, all of that stuff is digital. All of that information is passed as a string of ones and zeros. So when you listen to a song, the higher the bit rate, the better the quality. What they're talking about is the more ones and zeros that make up the song, the higher the quality music you're going to get. And we'll talk a little bit more about music here in just a minute. So a computer accepts data or input, and we'll talk about different ways to get information. It then processes information and produces information called output. So basically, it accepts data, it processes the data, and produces information. So data in itself is what's stored, and what we ask of the computer or query or ask questions is data. So most of you have heard of the idea of a database. That's all data, and we ask questions of those data, and it gives us back valuable information for us to make decisions with. So here's some standard computers that you're probably familiar with. Laptop computers. a tablet computer. So when we talk about laptops, we can be talking about Mac OS, we can be talking about Google Chromium today, we can be talking about Windows, we can be talking about open source like Unix and Linux operating systems on a laptop computer. Tablets, of course, you're probably familiar with iPads, and then Galaxy tablets for Android. So different operating systems, and we'll talk more about those in detail later. Desktops and or all-in-ones. So this is a computer. What we have here is the traditional desktop with the tower and the monitor and the keyboard and mouse. And over here is an all-in-one. So notice we still have the monitor and we have the keyboard and the mouse, and the computer actually sits behind the monitor. It's embedded in this monitor, sits behind. It's still a computer. It's still all of the components that we need. So exactly the same, just in a different form factor. Now the one that is missing here is what's called the 2-in-1. And what these are is these are laptop computers like this that either the screen disconnects from the keyboard and the ports on the side, and or can be flipped around and turned around and used as a tablet. So that's a 2-in-1 computer. And I have an additional video that you'll find in this chapter that details more of those, talks about different features and functionalities, why you might buy one computer over another, which is going to be pretty important with an assignment you're going to do here in the near future. So make sure you watch that video as well. I've also got an Excel spreadsheet that details all the computers that I talk about, their pricing at the time, and what you might find is the pricing continues to go down on this technology as more of it is produced. So other kinds of computing devices: smartphones, digital cameras. Yes, they have a processor, they have input, they have output, portable and digital media players, ebook readers, wearable devices, whether that's your new smartwatches or Google Glass, for example. And then, of course, gaming devices. So everything from gaming consoles, Xboxes, Sony PlayStations, to the new handhelds, which are making a comeback as well. So much higher quality screens and processors in those handhelds than we've had. So let's take a quick look at how information is passed, stored, and processed in a computer. So first we have to get information into the computer, and we call that input. So in this case, in our example here, a cashier either scans or enters items using a touch screen. So this could be a keyboard on the touch screen, or it could be a touch screen that's been programmed with common items. Simply touch it, put in the quantity. You've seen this if you've ever checked out through the self-checkout of a grocery store. So what happens is all of those items are stored in the computer in temporary memory. Usually what it's going to do is access a database. It's going to find the current price of the items. So that's what you see here. It stores the information. It then processes the information, adding additional data to it. So we've told it we have, say, one small turkey sub. That's all we've told it. It goes to the database and says, well, today, right now, one small turkey sub costs $3.49. What it does is it processes the data into an order, for example, and produces an output, in this case, a receipt that shows the total amount due, how much was received, the change, etc. So this is how things are processed in a computer. Same thing when we download software from the web. We're requesting software, it's being downloaded to the computer, it gets stored on the hard drive for permanent storage, and when we click on the software to open it up, the software is loaded into memory where it can be actively processed by the processor faster than reading it from the secondary storage. We'll talk about all that in more detail as well. So how do we get information into the keyboard, into the computer? Well, there's a lot of ways to do it. The most common is still the keyboard, whether it's an on-screen touch keyboard, a wired or wireless physical keyboard, an embedded keyboard in a laptop, an embedded or mini keyboard on a smartphone. Today, what we tend to see is on-screen keyboards on the touch screen. We don't see these slides anymore, or even virtual keyboards. So these are the idea where, based on where we're positioning our fingers on the tabletop, that's the key that's being pressed. And we know that most keyboards are done in what's called a QWERTY keyboard fashion, because the first keys spell out QWERTY, so QWERTY keyboard. Also, other input devices that are commonly used: touch screens, touch pads. Mice are still used, so this touchpad is simply another version of a mouse. So instead of moving the mouse around, we move our finger around on this touchpad, both of which use what's called an XY axis. So if you think about math and the XY axis, that's where it knows where this cursor is on the screen. So for example, up here I'm in negative, positive, negative, negative, positive, 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 negative. You get the idea. X, Y axis. And so that's how the computer is able to know, well, if this was an active icon here, I could click on it and it would do something because my cursor is over that area of the screen. So that's how a graphical user interface would be programmed. Some mobile devices and computers enable you to speak data instructions. Pretty amazing that now we can say things like, I got to say this quietly because I got a bunch of Google devices in my house. Okay, Google, and boom, I'm able to turn the lights on and off in my house. I'm able to set an appointment. I'm able to ask what my next appointment is. I'm able to ask and query the web. You know, who wrote what song in 1962, for example. Again, that's all information being processed by computers who are just simply searching the web. Scanner is another way to get information into a computer. We can scan pictures, we can scan books. The scanner you see here is a flatbed scanner. The reason we might still purchase a flatbed scanner today is because we get a higher dots per inch ratio. So dots per inch, you might be familiar with the idea of resolution of a computer screen. For example, the screen I'm recording this on is 4K. Okay, so it has a resolution with a certain number of pixels wide, certain number of pixels long. You know, in HD, we talk about 1900 by 1050, for example, those kind of numbers. And here, the higher dots per inch, the better quality scan. So if we equate that to a monitor, when we talk 4K, we're talking about 4,000 pixels in 1 inch of a monitor. Okay, so that's what 4K is. Give you a quick example of that. All right, so let's go ahead and we'll look at an output device. Output device is any hardware component that conveys information from a computer. The standard output device today is going to be a computer monitor. Now, this is going to quickly change because things like Google Home and Google Assistant, where we can ask a question and Google Assistant will give us back the answer in the form of audio output. So we no longer need to read the screen. We no longer need to read the screen. We'll actually get to hear the information that we've asked. So it's going to be amazing to see that artificial intelligence and that massive speed of searching the entire internet, and how Google Home is certain to make its way into business as well. A printer is another standard example. Today, of course, we don't just talk about 2D printers where we have paper and inkjet, and the inkjets onto the paper, creating characters that we can then read. That's output as well. But also today we can output to a 3D printer, you know, printing toys and prosthetics and eyewear and implants. And actually, a lot of small businesses are being started by someone buying a $500 to $1,000 3D printer and printing items, manufacturing items in small quantities that people want to consume. An example of this is I recently bought a mount for my Google Home Mini at home, and it was printed on a 3D printer. So the company got started, they were able to do their prototype, they were able to manufacture, and then finally their demand reached such a high level that they had to go out and get a company that could manufacture the quantities to meet the demand. So, but amazing that you now can buy an affordable 3D printer and print from your home 3D device, 3D items. You know, in this case, it looks like they're printing a piece from a chessboard. So 2D printing and 3D printing. All right, so that's 15 minutes. That's enough for this video. We'll catch you in part 2.